Hey pre-calc students, how's it going again? We are diving into 9.4 hyperbolas, and so before I want to get started, we'll talk about homework. Looks like I'm setting up a Zoom meeting. Hopefully y'all can attend, and I'm just using my notes here off screen. All right, so I want to talk about graphic calculators real quick, and then the Zoom meeting, I'd like to talk about where this equation came from. Also about homework and test quizzes and et cetera, et cetera. So give me a chance to talk to you about that in the meeting, but right now I just want to talk about hyperbolas. All right, so please read the definition of that in your book. Please take a look at the pictures of explaining it. You don't have to read everything. It's a math book. I mean, I'm not, I'm not born in the Stone Age. I do hope that you'll look at it and skim it, look at the definition, and then also look at the formulas. Okay, I want to talk about signs real quick. Okay. Oh no, I want to talk about your apps. Okay, or your programs. Oops, quit. Let's go to programs. Okay, or apps. You go to apps. All right, and go to conics here. All right, if you go to conics, and you can see that you should have all the conics that we've got. If you want an ellipse, all right, you hit ellipse, you've got two options. You've got one that opens in, if you can see, it opens wide in the x, and you got one that opens wide in the y. Okay, so the major axis is in the y, is along in the y, or if the major axis is along in the x. So say I chose this one, I want to fatten the y and the x, and then over here I have to hit the graph key, and that does it. Boom. So your graphic, this is not a function, this is a relation, so your graphic calculator can do this, but through this conics app. All right. If I wanted to do a hyperbola, okay, look at the formula. It's slightly different. Let's explore that real quick. If you see, this is the biggest difference right here between a hyperbola and a parabola. Okay, it's got that. So how do we identify them out, just like out of the blue? Well, if you've got this situation, 2x squared, and I'm going to ignore the xy, okay? So there's no xy term, okay? So if there's a 2x squared plus 2y squared equals 16, all right, I know that, and so if they have the same sign, all of these can be divided by 2, okay, to get rid of these. So, but the point is, if they have the coefficients are the same, so coefficients same and same signs, then this is a circle. Get my fat hand out of the way. Coefficients same signs, circle. Okay, after you've been playing with these. Okay, again, this is, if you just have to look at the term, oh sorry, the term with the x squared and the y squared terms. Okay, ignore all the rest. But that's only if there's no xy term under multiplication. All the ones we've done so far have no xy term. Okay, so now we have 2x squared plus 3y squared equals, and I'm just pulling these up. Okay, so this we know right out of the gates, this would be an ugly ellipse, because this number here, dividing this by all these terms by 4, because we want to set equal to 1. Remember, with circle, we're looking for the radius, and we don't set equal to 1. But with all the others, we're setting it to 1, and I'll explain that in the Zoom. Okay, but notice, same sign, addition, but different coefficients. So different coefficient, and same signs. Okay, I'm writing messy because this 15 minutes goes fast. Okay. Now we have an ellipse. All right. So as with parabola, I'm going to skip. Okay, with this parabola here, which we'll learn the next time. But 2x squared plus y equals 20. Okay. A parabola is easy. There's only one squared term, whether it's the x squared term or it's the y squared. This would be a parabola that opens in the x. It's actually be in the positive direction. So maybe something like that. Okay. This would be a parabola. A parabola is easy because it only has one x squared or one y squared term. It won't have a y squared. If it has an x squared term, it won't have a y squared term. Conversely, if it has a y squared term, it won't have an x squared term. Okay. Finally, the one we're learning today is, say you said something like 2x squared minus 2y squared equals 4, or something like that. They could have the same coefficient. Usually they don't, but they could have the same coefficient. but they have different signs. So this is a positive 2, and this is a negative 2. Okay, so different signs equals a hyperbola. Hyperbola. Okay. All right. Let's dive into this. Okay. Let's get working on a problem. Okay. So again, let me go back to this. Same signs, same coefficients are the same. Same signs, circle. Different coefficients, but same sign. Because if these are both negative, 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 then you divide everything by -1, and you can make these both positive. Okay. This one, differing signs, coefficient doesn't matter. They can be different or the same. Ellipse, different coefficients. Okay. They have to be different because they're going to be long in the y or long in the x. If they're not different, they're a circle. Okay. All right. This is number 2, I believe, in your book. So we've got 4. I'm going to go ahead and pause the video here. Okay, here we go. We have this problem here at number 2. All I've done is just rearrange the terms and add 344 to the other side. All right. Now I'm going to do the same thing that we typically do. All right. But remember, this has got a negative here. So I'm going to go ahead and factor out the 4 here. All right. Like we've been doing. X squared plus 4x plus, I don't know yet, although we've been doing this one quite a while now, so you should be, I'm going to put a plus there. Okay, I know it's going to be -9 I'm factoring out, but this is good to just have a plus. And then -9, because we can always do plus minus. -9 is being factored out, then we have y squared. And then if I factor out a -9 out of these two terms, then this becomes -12. Plus we don't know. Okay. Now I've got to write small because I wrote too big. So 344 plus 4 times something plus -9 times something. Okay? So, again, I'm going to add something to this left, actually 2 things. I'm going to add the product of 4 times this, and I'm going to add that to 344, and the product of -9 times this, and add it to the other side. I've got it. It's an equation. So what I do to one side, if I add it to this side, it won't. So I've got to add more here to balance it out. Okay. So this is pretty obvious. 4 divided by 2 squared is 4, and -12 divided by 2 squared is 36. Excuse me. And so then these two numbers are going to be 4, 36, 4, and 36. All right. I'm going to go ahead and pause and get this all the way down. Okay, so let me pause again here. Okay, so work this down. All right, factor out the 4. Okay, whole point of this is getting complete the square. So now this is x plus 2 quantity squared. This one now it's y minus 6 quantity squared. This, hey, conveniently adds to 36. All right. Divide every single term by 36. Okay, so I would divide by 36, divide by 36. Hey, 4 divided by 36 is 1/9. 9 divided by 36 is 1/16. Hey, how convenient. I went ahead and did not minus instead of plus minus here. Now, there may be confusion. Which is the better way? I mean, both are fine because they both mean the same step. I usually write in this form because I can already see something, just like the ellipses. I can see the x radius and the y radius. But you can leave this as just 3 squared and 4 squared in the denominator, okay? But I prefer to leave it in this method. Okay, so now let's talk about this, what this means, okay? Now, how do we know which direction that it opens up in, okay? So what I mean by that is, after you've looked at a hyperbola, you should see it either looks like this, or it looks like that, or it either looks like this, or it looks like that, okay? And then it has these asymptote lines here, okay, and asymptote lines here, okay? Well, how do we know? Let's first, before we do the asymptote lines here, how do we know which direction does it open? That's easy. Whichever one's positive. So they have to be different signs. Whichever one, so this one's negative, and x is positive. So we know that it opens in the x direction, okay? If the reverse were true, say it was negative here and positive here, then it would open in the y direction. So that's pretty easy. So this one is going to look like that. It's going to open in the x direction. The center of this hyperbola is at -2, +6. Opens in the x, centers at -2, +6. Now, what in the world do I do with these? Okay, I'm going to pause. I'm going to show you what the graph looks like and explains it. All right? Okay, let me pause. I'm going to flip the paper over because I'm out of space. Okay, so I've got this somewhat done. I got a little highlight, small tiny dots going on here. But so the center of this was at -2, +6. Okay, and then what are the asymptote lines? Well, you know that rise over run is going to be the change in y over the change in x. Okay, slope is change in y over change in x. Well, if you look at the denominators of the denominators were x, well, the equation were x plus 3 or x plus 2 of this minus this, okay, equals 1. 3 and 4. The y term, the y term is 4 and the x term is 3. The equation, so this is the x, again, this is the x radius and this is the y radius, okay? Oh, I can't see that. Okay, well, this is the x radius and that's the y radius. M, okay, M for slope is plus or minus y rad over x rad, okay? The y radius over the x radius. So in this case, it would be plus or minus 4/3. All right? And so going back to my drawing here, from the center, I just went up 4 over 3, up 4, whoops, or down 4/3. All right? And then now what? Well, this opens in the x direction. So the x direction right here. All right? And hold on 1 second. Let me double check. Okay, up against that time crunch again. So the x radius, since it's open in the x, is going to be 3 units. So from the center, I went 3 units over. Now the y radius is, it should touch the line from there and it should touch the line to there. I'm not going to care too much that that doesn't match perfectly. Okay, so you're going to open this up. It's going to open this up and you're going to try to get to the asymptote lines as fast as you can. Okay, whoops, don't go that way. And then it rides along the asymptote lines. Okay, it rides, it never crosses. Okay, and then on the other side, you're going to try to approach the asymptote lines as fast as you can. Okay, so your drawing then should look like that, and you've got your asymptote line here and bounded by those 2 asymptote lines, and that is your hyperbola. Okay, so I'm sure there might be lots of questions. Please text, email me. I only want you to graph one of them. I'm going to work 3 problems and graph one of them, look to the assignment, and then Lord willing on Tuesday let's have a Zoom and just kind of see where we're at. All right, God bless you and keep you. All right.